wamune.
Kids Kingdom Kindergarten and Daycare. Somero ly'abaana bato. Omuzadde leeta omwana ogenda okola ebibyo. Ebyokuzannyisa by'abaana byonna mu nsi tubirina. Ate ng'abaana we bazannyira wagazi nnyo. Jjukira security enka. Amasomero gonna gali mu kikomera. Abasomesa be tulina bakugu mu baana. Abaana tubaliisa bulungi nnyo munnange. Tulina main campus e Buddo Naggalabi nga bwakayisa Buddo Junior.
Good afternoon, viewers. My name is Mr. Kwagala John Mary. First of all, I would like to thank God for giving me this opportunity to interact with my students. And also, I'd also like to thank the management of May and High School, Green Hill Academy, and also BBS for giving us this opportunity to enable us to interact with our students when they're at home. Now, today I'm going to look at the topic. This topic is cross-cutting both in theory and practical. The topic is called redox reactions. Redox reactions. Let me write it in finally. The topic is redox. Redox reactions. Now this topic is covered both in theory and practicals, and also in O-level we also covered it just in summary, but when you come to A-level we expound it as you are going to be seeing. Now redox comes from two words, as you can see it. It comes from the words reduction and also comes from the word oxidation. So you might summarize it, or we just write this redox. Redox. So it means that you're having two reactions occurring simultaneously. We're having reduction and oxidation. Now the definition, you can just use this to that. Redox reaction is a type of reaction where both oxidation and reduction occur simultaneously. In other words, they occur at the same time. So redox reaction, type of reaction whereby both oxidation and reduction occur simultaneously, as we are going to be seeing. That's why they're called redox reactions. We set them in practicals. Number one normally covers this, whereby you're supposed to determine your values, theta values. Then after that, you are supposed to perform calculations, either getting the value of M or concentration or standardizing, anything that comes across. We also set them in theory, basically paper 1 and paper 2, because they involve calculations that require of a student in chemistry. Now, before we proceed, let us define the word oxidation. Oxidation is defined in two many terms, but for A-level chemistry, we are going to define it in terms of electrons. So what's oxidation? Oxidation is defined as the loss, refers to loss of what? Electrons. So when an element loses electrons, that reaction is called oxidation. I can give an example. It normally occurs in metals. Now these metals normally lose their outermost electrons. So this process of losing electrons is called oxidation. For example, we have magnesium. Magnesium is 2H2 at its O level. Maybe you can write 1s2, 2s2, 2p6, then 3s2, which is 2H, 2H2. Now they normally lose their outermost electrons and we form Mg, 2 positive, plus 2 electrons. Now we are losing electrons because we want to form a stable octet. So in this case, this is 2H2. we lose the outer S2 to have a stable electronic what? Configuration of a noble gas. So this is what we call what? Oxidation. So oxidation is the what? Loss of electrons. As you can see clearly here, magnesium is losing its electrons and you are forming magnesium ions plus 2 electrons. We can also define it probably in terms of addition of oxygen, which is basically move O level. Addition of oxygen. We have magnesium plus oxygen and we form magnesium oxide. Balance. That is also called what? Oxidation. We can also use hydrogen, but for A level, that made me stick on what? Electrons. Because there are three ways. You can say addition of oxygen, or you can also say the removal of what? Hydrogen from a compound. But for A level, we normally base on what? Based on electrons. I hope it's okay. Redox means reduction and then what? Oxidation. Then you also seen that oxidation is the loss of what? Electrons. Normally occurs in metals when they lose the outermost electrons from a stable electronic configuration. On the other hand, reduction is defined as the gain of what? Electrons. Gain of what? Electrons. Now, this normally occurs in nonmetals when they gain electrons to become what? Stable. For instance, let us take this sulfur. Sulfur normally acquires 2 electrons to become stable. So sulfur is 286, which is 1s2, 2s2, then 2p6, 3s2, yes what? That is 286, 3p4. 3p what? 3p4. 1s2, 2s2, p6, 3s2, 3p, 286. Yeah. Now it normally acquires 2 electrons to form a stable 3p6 configuration. So in gaining electrons, that chemistry is called what? Reduction. So in summary, oxidation, loss of electrons, normally occurs in metals. Then reduction is the gain of what? Electrons, normally occurs in non-metals. In terms of oxygen, is the removal of oxygen from a compound. So that's what we call what? Redox. Redox, before we look at redox, we have defined oxidation, loss of electrons in metals. Then for non-metals, that's gain of what? Electrons for reduction. For A levelers, I think now they're enjoying. A levelers, they're wondering why I'm wasting their time. But of course, this is an introduction. You cannot look at redox before looking at the what? The definition of those terms that occur in redox. So we define oxidation. We have given an example. Reduction, we have also given what? An example. Then after that, let us combine the two words, the two equations, oxidation and reduction, to look at redox reaction. Redox reaction. Let's have this example. We can take an example of magnesium plus copper oxide, where we form magnesium oxide plus what? Copper. Now in this equation, there are 2 terms occurring. But before we look at it, of course, you can clearly look at the portion of copper and magnesium. Of course, magnesium is above what? Copper. It displaces it from its what? Its oxide. The reverse cannot occur. It implies that you cannot have copper combining with magnesium what? Oxide, because copper is below magnesium. But this is possible because magnesium is more reactive than copper to oxide. So this places it from its what? Oxide. So in this case, magnesium becomes oxidized to magnesium oxide. Because oxidation, we have said the addition of what? Oxygen. So this is oxidation. That okay? Addition, we are adding oxygen to magnesium. That one is called what? Oxidation. At the same time, in the same equation, this copper oxide is losing its oxygen. Loses its oxygen and becomes what? Copper. And from our definition, reduction is the what? Removal of oxygen from what? A compound. So this one is called reduction. Good. So this type of reaction, whereby you're having both oxidation and reduction taking place, is called a redox reaction. Redox what? Reaction. Magnesium gets more oxygen, it becomes what? Oxidized. At the same time, copper oxide loses an atom of oxygen, it becomes what? Reduced. Now that's basically what? Olive. Then for A level, we have this zinc, an example, plus copper 2. We form zinc 2 plus copper solid. How do we explain in terms of redox reaction? We can pick out zinc. Zinc is going to what? Zinc 2 positive. So it says zinc solid is giving us zinc 2 positive aqueous plus 2 electrons. Then we go back to our definition. What's oxidation? Oxidation, loss of what? Electrons. This is loss of electrons. So this one is called what? Oxidation. At the same time, we have copper 2 going to what? Going to copper. So I have copper 2 aqueous are going to copper. Of course, when you balance this equation, we reduce the positive charge by introducing electrons, because electrons are negatively what? Negatively charged. So you say plus 2 electrons. And the gain of electrons, in this case we are gaining what? We are gaining electrons. Now the gain of electrons is called reduction. Loss is called what? Oxidation. Good. So you can clearly see that in this reaction, we're having both oxidation and reduction taking place. And therefore it's called redox reaction. I hope members you have got it clearly. We have defined very well in terms of oxygen, redox, oxidation, addition of oxygen, magnesium oxide. Also in terms of copper oxide losing the oxygen, we call it what? Reduction. Then in terms of ionic equations or electrons, we have seen zinc being oxidized to what? Zinc 2 positive. With oxidation, we lose the electrons. So this is oxidation. At the same time, the copper 2 ions acquire 2 electrons to form copper solid. This is called gain of electron, which is what? Reduction. So when you have both oxidation and reduction taking place in the same equation, that reaction is called redox reaction. Good. Let us look at oxidation states, oxidation number. Now the order for us, I think the understanding ends here. Let's look at A level now. Oxidation. Oxidation states or number. The definition, this is a measure of the extent to which an atom has been reduced or oxidized in a compound. That's the definition of what? Oxidation state on what? Number. Is the measure of the extent to which an atom has been reduced or oxidized in a what? In a compound. Now we can give an example of iron. When you have iron, solid, it gains, it loses electrons, sorry. We form two what? Two electrons. So iron 2 plus 2 what? Electrons. So in this case, this iron metal has been oxidized, iron 2 by 2 what? Electrons. Implying that the oxidation number for iron in this case is positive what? Is positive 2. That's what you are meaning, that is the measure of the extent to which an atom has been reduced or oxidized in a what? In a compound. So in this case, the extent to which iron has been oxidized is what? Is positive what? Positive 2. Implying that iron has an oxidation number in this case of positive what? Positive 2. Then for chlorine, you can say plus an electron and you form chlorine negative, aqueous. So also in this case, let me use, it's better use sulfur because this one is diatomic. You want to bring it very well. Use sulfur, then plus 2 electrons will form S2 minus, aqueous. So in this case, sulfur is gaining 2 electrons to form the sulfide what? Ion. So the extent to which this sulfur has been oxidized, so reduced, is what? It's positive 2. So in this case also, the oxidation number of sulfur is positive 2. Then for iron is what? Iron is 2. So that's what we call oxidation what? Oxidation number. The extent. This one has been oxidized by positive 2. This one has been reduced by what? Positive 2. An example, let us look at some calculations. Let's look at calculation of oxidation number or what? Or states. Or what? Or states. You can give examples. For example, let us begin with sulfuric acid. Sulfuric acid. So in this case, you are going to calculate the oxidation number of sulfur in sulfuric acid. So what do? We make sulfur to become what? X. Then sulfur is X. This is X. Then hydrogen has a state of what? Positive 1. So this one becomes positive 1 times 2, which is positive 2. Then sulfur is plus X. Then oxygen is negative 2. Negative what? Negative 2. So we say minus 2 times what? Times 4. Then now in this case, sulfuric acid has no charge. Has no overall what? Charge. In this case, we equate to what? To 0. So we get our mathematics here. That is 2 plus x minus 8 equals to what? Equals to 0. So now with mathematics, this is x minus 6 equals to what? 0. So x equals to positive 6. So that means that our oxidation number of sulfur is positive what? Positive 6. Hydrogen was positive 1, then multiplied by what? By 2, it became positive 2. Oxygens 2 minus, but there are 4 of them, which is minus what? Minus 8. 2 minus 8, that's minus 6. Mathematics to get positive what? Positive 6. So therefore, the state oxidation number of sulfur here is what? Is 6. Don't forget the what? The sign, positive 6. When you say 6 only without the positive, it becomes what? It becomes wrong. Another example, we can get the state in potassium dichromate. Let us get the one for what? Chromium. Chromium. How do we do this? Potassium has a state of positive 1 because of the metal, so it becomes 1 times 2. Chromium is unknown because that's what we want to get. You make it what? X. But we have 2 of them, so you say 2x. Then oxygen is a nonmetal, that's minus 7 times 2. Then in this case, we equate to what? We equate to 0 because the compound doesn't have any what? Any charge. Then you apply your mathematics. This is 2 minus 14, that's minus 12. So 2x minus 12 equals to 0. Equals to 0. That means that 2x equals to 12. We divide by 2, we divide by 2. So x equals to positive 6. So chromium has an oxidation state of positive 6. Positive what? Positive 6. You don't forget the sign. Now other compounds have charges. For example, let us look at the manganate. Manganate. Right. So the question is, find the oxidation state in what? In manganese. In manganese. So we make manganese to become X. Then oxygen, there are 4, and oxygen has negative 2. So that is 4 times negative 2. Now in this case, the species has a charge of negative 1. We don't equate to what? To 0, as we have been doing here. So we say equals to negative 1. So x minus 8 equals to negative 1. So x equals to positive 7. So in this case, manganese has an oxidation state of positive what? 7. Positive what? Positive 7. That's why it's called manganate. Manganate what? 7. Another example, let us look at some complexes. Potassium, iron. We want to get for iron here. Well, what we do? Potassium is positive what? Positive 1. 1 times 4. We want iron, so iron we make it to become what? X. Then plus. Now cyanide has a state of negative 1. Negative what? Negative 1. That is 4 here minus 3. That is times what? Times 6. We equate to 0 because the complex has no what? Has no charge. So we say 4 plus x minus 6 equals to what? Equals to 0. So what is x here? 4 minus 6, negative 2. Negative 2. So x here equals to positive what? Positive 2. So after getting this answer, you go ahead and you say iron has an oxidation state in that one of what? Positive 2. Positive what? Positive 2. That's how we can calculate what? Oxidation what? Number or state. You make that number to become what? They wanted the number to become x. Then after that we expand. If this is h1, you say positive 2 plus x minus 2, you get positive what? Positive 6. The same applies to others like that. So I've seen here sulfuric has a positive 6. Chromium has positive 6 here. Manganese has positive what? Positive 7. And iron here has positive what? Positive 2. That's how we calculate oxidation what? Oxidation number. I think that example, do I read another example? This is 1, 2, 3, 4. I think those are enough examples. Good. Now I want you to also, during your free time, to get the state of these ions. Let me write them here. You can jot them somewhere. You get for DH4. You get for beryllium. Which other complex? We have get for iron. Then you have the thiosulfates. Get for sulfur. Which other one? Can also get for nitrogen here. So during your free time, you can calculate those oxidation what? States. State for beryllium in this complex, iron in that complex, sulfur in this species, N in what? Nitric acid. Let us look at what? Let us look at names of some common compounds. I think it's okay, it's not hard, it's easy. So long as you know the states. Oxygen is 2 minus 2, and metal. Then for potassium, 1, which is positive 1, since it's a what? It's a metal. Now naming of, let us look at names of compounds based on their oxidation states. We have MnO2. We have that one. We have then we have O4. We have which other one? We have also here we have which other one? Potassium Dichromate, chromium what? Manganese. Good. Which other one? Great. I think these ones can work. No, can also add these complexes. Six. Supposed to be 4. Now, how are these complexes named? Those are complexes. These are just oxidizing agent. So this one we get for manganese. Can get very fast. This is X, unknown. Oxygen is 2 times negative 2 minus 4 equals to what? 0. So X equals to positive what? Positive 4. So this one is called manganese 4 oxide. Even here you can get for chlorine. Okay, we have this one now. I can also name this. We have this one. You can get the value of X. This is 1 positive. this is X, this is oxygen is negative 2, which is minus 6 equals to what? 0. So X equals to positive 5. So this one is called potassium chlorate 5. The 5 normally stands for what? The oxidation number of what? Chlorine. Then this one we have already calculated it there. It's called potassium manganate. Manganate what? 7. Potassium manganate what? 7. What about here? Now this one you can first calculate. Potassium is a metal that's positive 2. Positive 2 plus X here minus 8. Does it have any charge? No charge. Equate to what? 0. So X equals to positive what? Positive 6. Equals to minus 8. That's minus 6. X minus 6 equals to 0. That's positive what? Positive 6. So this complex is called, no, not the complex, sorry. This compound is called potassium manganate. Manganate what? 6. This one I've already calculated the chromium. So it's called potassium dichromate. Dichromate what? 6. Now this one this is you name this and even this one. Now here we calculated the potassium. Iron was having what? Positive 2. So this one is called potassium hexacyano. Cyan is here. Ferrate. The state of iron is what? 2. Ferrate what? Ferrate 2 ions. So that's how we name some of the compounds basing on their what? States. Potassium chlorate 5. We have chlorate 3. We have chlorate 1. etc. So you can normally name the compounds basing on the oxidation what? Oxidation number. So 5 how many numbers? 1, 2, 3, 4. They are very simple numbers. You can just look at them and even give the what? Give the answers. Good. It's normally set. The mistake people normally do is that after calculating, when the answer is positive, someone forgets a positive and says that set is what? 7. Once you do that, we cross that because a positive is very important as far as what? Chemistry is what? Is concerned. I think we are still okay. Good. Then after that, let us look at common oxidizing agents. Common oxidizing what? Agents. I hope you are still writing. You can write. Let me give you some 1 minute. And I hope also you are busy at home. Don't rest. You can get numbers from Tubies, numbers from, of course, from online numbers, WhatsApp, such that you keep your brain active. Otherwise, by the time you come back, I don't want you to come back when you cannot even write the formula of what? Potassium thiocyanate. So some of those things you can keep on doing them. You wake up, do some of those numbers, and make your brain active. Good. Now, some oxidizing agents. Oxidizing. Now, we have talked about oxidation and reduction. Now, I have talked about oxidizing agents and reducing what? Agents. Now, these ones normally accept electrons. Accept what? Electrons. And they are reduced. And they are what? And they are reduced. They are reduced. So these are electron acceptors. And they normally do what? And they are normally what? Reduced. An example is chlorine. Chlorine. Oh no, here means manganate. An example we have the manganate, but manganate is a little bit hard for now. Let me use chlorine plus 2 electrons. We form 2Cl minus. This is, let me use the atom. I prefer writing sulfur. Sulfur is better. Sulfur plus an 2 electrons form what? Sulfur. This is, but the best is chlorine. Chlorine form 2Cl. Let me write sulfur. Sulfur is a weak one. The good oxidizing agents and group 7, let me use that, chlorine. So in this case, chlorine is an oxidizing what? Agent. It accepts electrons and becomes what? Reduced. Another one, we have the manganate. We have the potassium manganate. We have manganese oxide. We have potassium dichromate. We have hydrogen peroxide. This is both oxidizing and reducing. We have iron 3. The list is long, but you can write those ones. But the common ones that normally use are potassium manganate and potassium dichromate. Those are oxidizing what? Agents. So oxidizing agents are electron acceptors, and they are reduced in terms like here. This one has a state of 0. After accepting electrons, it becomes negative, as you can see, times 2. So in this case, it has been what? Reduced from 0 to negative what? Negative 1. I can also add chlorine here among oxidizing what? Agents. Good. Then you have reducing agents. Reducing agents. Reducing agents. These are electron suppliers, and they are normally what? They are normally oxidized the reaction. The common examples you have are, we have potassium iodide, we have the oxalate species. Let me take sodium oxalate. We have sodium sulfite. We have hydrogen peroxide also. We have tin 2. We have iron 2. All those are what? All those are reducing what? Agents. Now they supply their electrons, and the resultant is the species being what? Oxidized. Let us look at outright redox what? Equation. I know for some you are just revising. The senior 5s, I think also it's not too hard. You can try to pick up this, because now we are supposed to be doing redox reactions in practicals and also some theory what? Lessons. I think they are not so hard. So far, the work I think is flowing very well, and I know you're there enjoying. These are laughing and very happy. That's good. Reducing agents are those ones. We have the hydrogen peroxide, oxalate, etc. Good. Now let us look at still oxidizing what? Agents. Oxidizing agents. We have the potassium manganate. We have also there's lead oxide. Forgot it. We have potassium dichromate. We have hydrogen peroxide. We have iron 3. Iron 3. What else? I think these are the basic one, and even manganese 4. Now in these oxidizing agents, we have species which are active species. Active. Like when you are taught to write a half equation, you are supposed to get the active species in potassium what? Potassium manganate. In this case, the active species is what? Is the manganate. Is the what? is the manganate. Active species, and the manganate is being reduced to what? Is being reduced to manganese 2 ions. Manganese to what? Ions. Purple, this is purple in color, and this is colorless. Or sometimes can be faint what? Faint pink. The lead oxide, the active species is also the lead oxide, PbO2, and this one is going to be reduced to lead what? Lead 2. In potassium dichromate, my students, the active species is a dichromate. Now dichromate is orange. It goes to chromium 3, which is what? Green. I think the O-level students, you know this, that the potassium dichromate is tested for the presence of sulfur dioxide what? Gas. So it turns from orange to green because of formation of chromium 3 ions. Then peroxide, the active species is HO2, and this one is going to be reduced to what? Reduced to water. Reduced to what? Water. Then iron 3, the active is iron 3, and it's going to be reduced to what? Iron 2. The colors, this is yellow, and this is green. Then manganese oxide, this is MnO2, is active species, and goes to Mn2 positive. So these are the oxidizing what? Of course, there are many. We have sulfuric acid. We have nitric acid, because nitric acid is a strong oxidizing agent compared to sulfuric what? Acid. It goes nitrogen what? Dioxide. But let us focus on these ones. The manganate, you cannot escape the manganate. You cannot escape the peroxide. You cannot escape that one. Also this one, because they are normally the relatives. And someone, this one. This one of course occurs in what? Mainly group 4. So these are the oxidizing agents. And these oxidizing agents have what called active species. Which active species we have in the potassium manganate? Is the manganate. What about nitric oxide? It means that potassium dichromate, we have the dichromate. Peroxide, iron 3, we have iron 3. Manganese for what? Oxide. Now let us write half equations for these reactions. I'm going to pick out the manganate. I'll skip this for you. I do that. This is, do that. For you, are going to do this one, and that one. Of course, when you are teaching, normally pick up the easier one and leave the difficult one to the what? The students, so that they can get the skills of writing half what? Half equations. Half what? Half equations. Good. Manganate. So when you're writing half equations, you write the starting species in the manganate. Manganate. Aqueous. This one goes to manganese 2 ions. To what? 2 ions. Then after that, you look at your equation, you admire it for just for 1 minute, and find out which one is not balancing that what? That equation. Because for chemistry, balancing equation is part and parcel of writing a proper what? Equation, being a chemist. So after looking at it critically, the charge is not balanced, the atoms are not balanced, so you get disturbed, and then you start wondering how can you balance the what? Equation. Now in this case, when you're balancing a half equation, we call them half equations, please. This is called half equation. If you remember very well in O-level, when you're doing the Daniel cell, we used to write half equations. So even here we have a half what? Half equations. So we start our half equation. This is an oxidizing what? Agent. You can even find out how it's oxidizing it. This one is said that manganese is positive what? Positive 7. Because this is x minus 8 equals negative what? Negative 1. it's going to positive what? Positive 2. In other words, an oxidizing agent, after combining with another species, it becomes reduced to positive what? Positive 2. So we balance our equation. So there are 4 atoms of oxygen. Now when you're balancing oxygen, you introduce water molecules to balance oxygen what? Atoms. Now since there are 4, we say plus water, plus what? Water. But after putting water, ask yourself, how many molecules of water do we need to balance the atoms of oxygen? Since we have 4 here, and each water molecule has 1 atom of oxygen, that automatically implies that we put here what? A 4. Of course, don't forget the physical what? Physical states. Of course, after introducing in water, we get more problems. Because now we have excess hydrogen what? Ions. So of course, when you have problems, you get solutions. So we say plus 8H positive. Now in this case, the atoms are balanced. You can now can a little bit smile. Manganese 1, 1 that side. Oxygen 4, 4. Hydrogen 8, even there what? 8. But you don't relax, you keep on checking out. At this side, we have a charge of what? Net charge. Negative 1 plus 8. That's positive what? Positive, negative 1, positive 7. Good. What about here? Positive what? Positive 2. Now, an equation is only balanced when both the atoms and the charge is what? Is balancing. So, introducing something which can reduce the what? The positive charge. And when you are balancing these equations, we normally use electrons. And the electrons are negatively what? Charged. And these electrons being negatively charged, they reduce on the positive value. So in this case, you don't put electrons here. You put them where? Here, because here we have a higher positive value, which can only be reduced by using what? Electrons. How many do we need to balance? Positive 2, 7. 7 minus 2 gives us what? Positive what? Positive 5. That means that we introduce in 5 electrons. So we say plus 5 electrons. So this one becomes our, let me write it proper here, 8H aqueous plus the manganate then plus 5 electrons, we form manganese, 2 positive aqueous plus 4 moles of what? Water. That is our half what? Half equation. Clearly balanced. The atoms are balanced, even the charge. This is, can check out, 8 minus 1 minus 5. That is positive what? Positive 2. Even here positive what? Charge is okay. What about atoms? Manganese 1, 1. Good. Oxygen 4, even there 4. Wonderful. 8H, 8. Good. Can even mark yourself. That's the half what? Equation. Color change. Purple. Solution turns to what? Colorless. Dichromate. You can write the dichromate because these are the key oxidizing agents. Goes to what? Goes to chromium. You write it, then you give it at least some distance. Look at it, admire it. When you look at it critically, chromium, is chromium balanced? No. Oxygen not balanced at all. So in this case, we begin with what? With chromium. There are 2 here, so put a 2 here. Good, is it balanced? Wonderful. Chromium is okay. But still, oxygen is not what? Balanced. And we have said that these equations, to balance oxygen, we normally introduce in a molecule of what? Water. Water, this side which has no what? So plus water. But after that, you ask yourself, but water has 1 atom of oxygen. These ones are how many? 7. So what do? You say plus 7 molecules of what? Of water. Good. You can now give it a distance, chromium 2, oxygen 7, 7. Hydrogens now they have become excess. They are now 14. Here you have nothing. So in this case you say plus 14 H positive. aqueous. Aqueous, H positive aqueous. Then after that, atoms are balanced. You look at the what now what? The charge. This side you have a charge of what? 3 times 2, positive 6. What about here? 14 minus 2, positive what? 12. Now we said that when you're introducing in, when you're balancing charge, use electrons. And the electrons are supposed to be put on the side which has a higher positive what? Value. In this case, it is here. This is positive what? 12. Then after finding that this one has a higher positive value, how many electrons do we need to balance this? Just say 12 minus 6, it gives us what? 6. So you say plus 6 electrons. So write your half equation, 14H positive aqueous plus dichromate aqueous plus 6 electrons will form 2 chromium plus 7 what? Water molecules. Observation, purple. Sorry. Orange turns green. This is purple. Colorless. Now because of time, I can write this very fast. Probably you can balance it. You can just use this analogy. MnO2 goes to what? Manganese 2. Oxygen there are 2, so bring into water molecules. So say plus 2 what? 2 water. 2 water. So hydrogen they become excess. You say plus what? Plus 4H aqueous. After that, look at the charge. Positive 4, positive 2. So you say positive what? 2 electrons. Then this is a solid aqueous liquid. So those are what we call half equations. Half what? Equation. Now because of time, I've given an assignment. You can write for us the half equation for that. You can write also here this peroxide going to what? No. Peroxide going to water. You also write ion 3 going to what? Ion 2. You also give the observable what? Observable changes. Good. I think that assignment will be enough for you this weekend. I want to pray that God gives us life so that we can meet next time. And also I'm encouraging my students to always be active. Don't be at home and just watch TV and just watch soaps. Please try to do some numbers. You can do numbers from 2B, numbers from the online numbers. Yeah, because some schools are sending numbers. Don't just sit at home, please. I'm repeating this. Always try to be what? Active. At this time, I would also want to thank the administration of BBS, Mayor High School, Green Hill Academy, for giving this opportunity to interact with my students. Though I'm not seeing them, but I'm sure that they're at home watching, even other students. And I'm hoping that this interaction is positive and will yield a better performance. I hope so. Come, the name when it's going to be what? Done. God bless you. Have a nice what? Nice time.
Somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi lusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe